Hi, I like to go over some acid-base terms with you quickly just to make sure that you're up to speed and understanding all the vocabulary. So an H+, this is just the hydrogen ion. We also call it a proton. OH-, that's a hydroxide ion. H3O+ is a hydronium ion. Now, just so you know, in chemistry, we use these two interchangeably. So if I write the concentration of hydrogen, that is the same thing as the concentration of hydronium. So don't let that throw you. As chemists, we'll use that interchangeably. This is just showing a water that's attracted to that hydrogen ion. Same thing. All right, amphoteric. That is a species that can act as both an acid or a base. Water is a good example. Something like hydrogen carbonate would also be an example. It can either gain a hydrogen or lose a hydrogen. Remember, an acid is going to donate a hydrogen, a base is going to accept a hydrogen. Equivalence point, this is where the moles of the hydrogen, in essence the moles of the acid, equal the moles of the base, the hydroxide. Really important right here, it's moles. So important that you know it's moles. It's not molarity, it's the moles equal each other. On a titration curve, it's right there in the middle. That's your equivalence point. The end point, this is where an indicator will change color. You might go from like let's see, a yellow to a green, and that green tells you that you've reached the equivalence point. When you actually see the color change, that's called the end point. The halfway point, this is where pH equals pKa, and it's right here in between the initial and the equivalence. That's the halfway. It's also called the midway, the half equivalence point, ideal buffer. It's really special because pH equals pKa, and it's where the acid, sorry, that's an A, the concentration of the acid equals the concentration of its conjugate base. You've actually added half of the volume needed to reach the equivalence point. So that's where you get that word half. Just a little reminder, pH stands for per hydrogen, POH per hydroxide, pKa is per Ka, and this all comes from simply the meaning that we're looking at the amount, the concentration, and it's an easy way to take concentration that's kind of ugly, like a 10 to a -6, and make it into a really pretty number and say, oh, pH is 6. How we do that is with this formula, pH equals negative log of the hydrogen ion, and that would carry through with POH and pKa. Now, all of these, every single one of these has in-depth videos available under the acid-base equilibrium playlist. So go ahead and look at those. This is just a really quick overview to examine vocabulary. So proud of you that you're doing acid-base equilibrium. It's not for the faint of heart. You keep going, drink orange juice, get vitamin C, make sure you're getting enough sleep and water, and now you can do acid-base. Have a good day. Thanks.